Compute the shear force and bending moment diagrams for the beam as shown and find the maximum deflection. Assume rectangular cross-sectional area of 0.2 meter and 0.3 meter. Young's modulus of 210 gigapascal and Poisson's ratio 0.27. So in this problem statement, so we are using simply supported beam which is subject to a uniformly distributed load for 4 meter length up to 4 meter length. So that we are going to analyze the beam and compute the shear force and bending moment diagrams, and also we are going to find out the maximum deflection. So here we are going to use the ANSYS software. So in the ANSYS software, first create the element type, go to element type, add edit delete, add beam element. Then go to material properties, material models, structural, linear, elastic, isotropic, Young's modulus 210 gigapascal. Here we used the unit system Newton and meter square. So 210 into 10 to the power of 9, that is E9 Newton per meter square. The Poisson's ratio which is given, that is 0.27. So now enter 0.27 the PRXY tab. Then click OK and go to sections, beam common section. So use the rectangular section. So in the rectangular section, so B is 0.2 meter, breadth is 0.2 meter and height is 0.3 meter. Then click OK. So now I am going to construct this geometry using 3 key points. So key point 1 is origin. There is first key point is origin 0, 0, and key point 2 is 4 meter. There is 4, 0, and key point 3 is 6 meter length. That is the coordinate value is 6, 0. So now modeling, create key points, inactive coordinate system. Key point 1 is 0, apply. Key point 2 is 4, apply, and key point 3 is 6. I created 3 key points. Now I am going to create the line by joining these 3 points. There is line 1, there is straight line. Click straight line, key point 1 and 2, and key point 2 and 3. So I created 2 lines. Now I am going to mesh this model. The total length of the beam is around 6 meter. So that I am going to divide the entire length of the beam is 60 element. That means there is for 1 meter length I am going to divide into 10 elements, so that the total number of total length of the beam is 6 meter. So that I am going to divide the 60 number of elements. So meshing, mesh tool, lines set. First pick the line, select the line. I am going to select the line, first line, and then apply. This line is 4 meter length, so that the number of element divisions are 40. Then click apply and select the next line, apply. This line is 2 meter length, so I am going to divide the number of elements are 20. So totally 60 equal number of elements. And use the raise and hidden button. So I am going to retrieve the mesh tool and click mesh and then pick all. So now I am going to apply the loads and boundary condition. Here it's a simply supported beam, so that loads, define loads, apply structural displacement on nodes, select the left end and right end of the right hand nodes of the beam, click apply, and I'm going to select ux, uy, uz, rotx, roty will be 0. The displacement value will be 0. Then click OK. So now I'm going to apply the pressure load, that is a uniformly distributed load. The uniformly distributed load of 12 kilonewton per meter, that means 12,000 newton per meter along 4 meter length. So here how to find the 4 meter length? So here I already divided into 40 number of elements. So that first we have to select the elements attached to the first line. So I created two lines, the line number 1 and line number 2. First 40 elements are attached with the line number 1, and the second rest of the 20 elements are attached with the line number 2. So this is the concept, so that I am going to use select options, select entities, lines. First I am going to select the lines by number pick. I am going to use the pick, or I am going to use the numbers, and click apply, then select the line, first line. So here there is highlighted only the first line because we created two lines, then click OK. So now I'm going to use the select option, entities. So in this line 40 elements are attached with with this line, so that elements attached to the lines, already selected lines, then click OK. Elements attached to lines, then click OK. Now now I'm going to use the plot option, the plot lines. Here only plot elements. Here only the elements which are attached with the line number 1. The elements are displayed which are attached with the line number 1. So now loads, define loads, apply, go to pressure load on beams, and select the entire length of the beam. Here the total number of elements only in 4 meters, up to 4 meters are displayed, so that we can easily select the entire length of that is up to 4 meter length. Then click apply. The pressure key, the load key, there is along y direction because UDL is acting along y direction. The pressure value there is 12 kilonewton per meter, that is 12,000 newton per meter. If uniformly varying load, we can give the uniformly varying load, we can give the another force value, or otherwise we can leave blank for uniform pressure. Then click OK. So now the low UDL is applied up to 4 meter length. So now go to the select option, select entities, sorry, select everything. So the models or lines which are everything inside the window we are going to select. So now the plot, multi-plots. So now the entire geometry is displayed. So here up to 4 meter length we applied the uniformly distributed load. So rest of the length of the beams are free. So now it is simply supported. So now the pre-processing stage is completed. So go to solution, solve current load step, then click OK. So first we are going to compute the shear force and bending moment diagram. So go to general processor. Here we are using some options to find the shear force and bending moment diagrams. So go to element table and define table, add. So in this option select the by sequence number. The right side box there is SMISC, and enter the values are 3, apply. Sequentially we are going to give the option there is SMISC 3, 6, apply. By sequence number 16, apply. Similarly by sequence number SMISC 19. Okay, 4 kind of data values are required for plotting the shear force and bending moment diagram, then close. 3, 6, 16 and 19. So now go to plot results, contour plot, line element results. So in this line element results, so the element which has two nodes, the node I, we can use the data, there is SMISC 6, and node J SMISC 19. So these two options are used for plotting the shear force diagram, and then click OK. So we can get the shear force diagram. So now we can plot the shear force diagram. So go to plot control, using style, colors, you can change the background. So white background, so that we can easily plot in the printer. So reverse video. So now you can use the plot controls, capture image, save as the BMP image, and you can plot. Then the bending moment diagram. So go to line element results. So now you can use the element table item at node I is 3, element table item at node J is 16, and click OK. So this is a bending moment diagram. You can plot this bending moment diagram by using the previous options. So now we are going to plot the maximum deflection. So I'm going to change the two-dimensional problem into 3 dimensions. So go to plot control, style, size and shape, on. The display of element is on. So now plot results, contour plot, nodal solution, displacement, vector, sum. So you can use the isometric view. So you can see the displacement plot of the beam. The maximum displacement is 0.003646 meter. Okay, thank you.